The moon, Earth's celestial companion, has always held a special place in human imagination. For millennia we have gazed up at its familiar face. But what about the other side, the side that remains perpetually hidden from our view? This hidden hemisphere, often referred to as the dark side of the moon, has long been a source of mystery. The term dark side is actually a misnomer. It signifies the side that faces away from Earth. This side experiences day and night cycles just like the near side. The moon's synchronous rotation is a delicate balance of gravity and motion. Imagine the Earth and the moon as partners in a celestial waltz. As the moon orbits our planet, Earth's gravitational pull exerts a slight tug on the lunar surface. This tug creates a bulge, known as a tidal bulge, on both the near and far sides of the moon. Over eons, this constant tugging from Earth's gravity gradually slowed down the moon's rotation. Eventually, the moon's rotation period synchronized with its orbital period, resulting in the same side always facing Earth. Think of it like a ball on a string. As you swing the ball around your head, you'll notice that the same side of the ball always faces you. The moon's synchronous rotation is analogous to this, with Earth's gravity acting as the string. This gravitational lock, while responsible for the hidden hemisphere, also plays a crucial role in stabilizing the moon's orbit and influencing Earth's tides. For centuries, the far side of the moon remained a realm of pure speculation. It wasn't until the dawn of the space age that we finally caught a glimpse of this hidden hemisphere. In 1959, the Soviet spacecraft Luna 3 beamed back the first grainy images of the far side, revealing a landscape strikingly different from the familiar near side. These early images sparked a wave of excitement and curiosity. The far side, as revealed in these initial glimpses, was a world of rugged highlands and a multitude of impact craters, a stark contrast to the smoother, darker Maria that dominate the near side. Subsequent missions, including the Apollo missions and more recently, the Lunar Reconnaissance Orbiter, have provided us with increasingly detailed views of the lunar far side. These missions have helped to map the topography, study the composition of the lunar surface, and unravel the geological history of our celestial neighbor. While the initial mystery surrounding the far side has been lifted, these missions have revealed a wealth of scientific treasures, offering insights into the formation of the moon and the early solar system. The shroud of mystery that once enveloped the far side of the moon gave rise to a plethora of myths and conspiracy theories. Some speculated that the hidden hemisphere harbored secret alien bases or even lost civilizations. Others imagined it as a dark and forbidding place, home to strange creatures and unknown dangers. However, as our understanding of the moon grew, these myths were systematically debunked. The missions that orbited and landed on the moon found no evidence of alien life, secret bases, or any other such extraordinary claims. The far side, while different in appearance from the near side, is governed by the same laws of physics and exhibits the same geological processes. It is a testament to the power of scientific inquiry that what was once a realm of pure speculation has now become a well-studied and understood part of our celestial neighborhood. The debunking of these myths, however, does not diminish the allure of the moon. Instead, it redirects our focus towards the genuine scientific mysteries that the lunar far side holds. Section 5. A harsher landscape, craters and silence. The far side of the moon presents a starkly different landscape compared to the familiar near side. One of the most striking differences is the abundance of impact craters. Unlike the near side, where vast plains of volcanic basalt, known as Maria, are prevalent, the far side is heavily cratered, bearing the scars of billions of years of impacts from asteroids and comets. This difference in cratering is thought to be due to the near side experiencing more volcanic activity in the past. The molten lava from these eruptions flowed into and filled many of the impact basins on the near side, creating the smoother Maria we observe today. Another notable difference is the absence of large Maria on the far side. This suggests that the lunar interior might have cooled and solidified more rapidly on the far side, hindering volcanic activity. The far side's heavily cratered terrain and lack of Maria create a harsher and more ancient landscape, a testament to the relentless bombardment from space that the moon has endured throughout its history. Section 6. Echoes of the Early Solar System Scientific Treasures. Beyond its stark beauty, the far side of the moon holds immense scientific value. The abundance of craters provides a record of the early solar system's bombardment history. The far side's lack of volcanic activity preserves the ancient lunar crust. Its radio silence makes it ideal for sensitive radio telescopes. These treasures promise to revolutionize our understanding of the universe. Section 7. The Lunar Gateway, a stepping stone to the stars. The far side of the moon is not only a scientific wonderland, but also a strategic location for future space exploration. NASA's Artemis program aims to establish a sustainable presence on the moon, including a lunar gateway, a space station in lunar orbit. The far side, with its unique advantages, is being considered as a potential location for elements of this lunar infrastructure. Its radio silence makes it ideal for communication with Earth, while its proximity to the lunar South Pole, a region believed to contain water ice, makes it strategically valuable for resource utilization. The Lunar Gateway, positioned in lunar orbit, would serve as a hub for scientific research, resource prospecting, and as a stepping stone for future missions to Mars and beyond. The far side of the moon, once a symbol of the unknown, is poised to play a pivotal role in humanity's next giant leap in space exploration. As we venture further into our cosmic backyard, the far side of the moon will undoubtedly continue to captivate our imagination and fuel our thirst for discovery. Section 8. Unanswered Questions, the Allure of Exploration. Despite the significant strides we've made in understanding the far side of the moon, many questions remain unanswered. The precise mechanism that led to the asymmetry between the near and far sides, with their stark differences in cratering and volcanic activity, is still being investigated. The composition and distribution of minerals and resources on the far side, particularly the extent of water ice deposits, require further exploration. The potential for using lunar resources to support future missions, and even establish a permanent human presence on the moon, is a tantalizing prospect that drives ongoing research and exploration. The enduring allure of exploration lies in the pursuit of these unanswered questions. Each mission, each discovery, brings us closer to unraveling the mysteries of the universe and our place within it. The far side of the moon, once a blank canvas for our imaginations, is now a frontier of scientific discovery, beckoning us to explore its hidden wonders. Section 9. The enduring fascination with the lunar far side. The far side of the moon, once shrouded in mystery and the subject of countless myths, has now emerged as a frontier of scientific discovery and a stepping stone for future space exploration. While we have learned much about our celestial companion, the far side continues to captivate our imagination, reminding us of the vastness of the universe and the boundless potential for exploration that lies ahead. As we gaze up at the familiar face of the moon, let us not forget the hidden hemisphere, a testament to the enduring power of scientific curiosity and the relentless pursuit of knowledge. The far side of the moon, once hidden from view, now beckons us to unravel its secrets and explore the boundless possibilities that lie beyond.